In our last lesson, we learned how to evaluate functions given a function in function notation. So remember, if we have function notation, this is read as f of x. And if we want to evaluate the function at f of 1, all we're doing is taking that 1 and plugging it in anywhere we see an x. Now today, we're going to do something different. Not all functions are expressed as equations. Sometimes they are expressed as graphs. You can still use function notation to express the outputs for various inputs from a graph. So remember, outputs are what? The x or the y? It's the y. Inputs are your x values. Do you remember y is the same as f of x? So in this case, here it is written, x is the input and is the x coordinate in the point x comma y. When a problem asks you to find f of x, you're looking for the y coordinate because f of x is the same thing as y. They're the same thing, just two different ways of saying it. So here's an example. It says find f of 2. Notice here, usually it's read as f of x, right? This isn't f times x, it's f of x. Now we have a 2 in the place of x. So on the graph, we're going to find 2 on the x-axis. Now this is our x-axis here. So, and it's labeled right here, x. So we're going to go to 2 on the x-axis, which is right here. And we're going to go up along there until we hit this function here. So when x is 2, what is our y? When x is 2, our y is 3. Oops. Now, our y coordinate here is 3. So another word for y, how do we express y? F of x. F of x. So in this case, f of 2 is equal to 3. Right? So when we go to our x value of 2 and we hit our function, our y value is 3. So we write that f of 2 is equal to 3. Let's try these problems here. The first one says find f. That's not f times 4. That's read as f of 4. And remember, it's usually written as f of x. So now we have 4 in place of x. So we'll go down to our x-axis here, and we're going to find 4, which is right here. So then I'll follow the 4 up along that x. X is equal to 4 all along here until we hit our function, which is right here. Now, what's the y value there? Well, we'll go all the way to the left to the y-axis, and we hit the y-axis at 6. So that means f of 4 is equal to 6. The input of 4 has an output of 6. How do we do that? From looking at the graph, wherever that x value hits the graph, and we check out the y value. Find f of 0. Again, our x is being replaced by 0. So we'll take a look at the x-axis, which is 0 here. So we'll follow that x up until we hit the function, which is right here at 3. So we write that as f of 0 equals 3. That means the input of 0 has an output of 3. Now find f of 9. 9 here is in the place of what? X. So again, we look at our x-axis and we find the 9. We go up until when? How do you know when to stop? You know when to stop when you hit your function, which is right here. And then we need to look at that y value. So we go to the left, and there we go. We have 3 again. So that means f of 9 is equal to 3. I notice that the input of 0 has an output of 3 and the input of 9 has an output of 3. Is it okay that these two inputs have the same output? Yes. Here's why. Remember the rule of functions? Each input can only have one output. Well, is that still true? The input of 0 has an output of 3. The input of 0 doesn't give you anything else but 3. And the input of 9 only gives you an output of 3. Also, it's okay that they have the same output as long as it doesn't have any other outputs on that same line here. So that is okay. So let's try some practice ones here. F of negative 2. So our input is negative 2. I'm going to go to the graph and I'm going to go start at 0, our origin, follow along the x-axis here, go left 2, and then I need to reach my function. So you see that function here? Wherever it hits that function. So go to the left 2, go up until we hit our function, and now we check out the y value, which is right here. And that y value is 1, 2, 3, 4. So f of negative 2 is equal to 4. What is f of 2 equal to? So we start at our origin, we go to the right, 1, 2. And now our function's down here, so we have to go down until we hit it right here. And let's check out that y value right here. That hits the y-axis at, you're going down 2, so that is negative 2. Now we have f of 5. What is the value of f of 5? Start at our origin, go to the right, 5, and then go until we hit our function, which is down here, negative 1. How do I know it's negative 1? Because we go down 1, matches up with that y value, that on the y-axis. What do we get for f of negative 4? Start at the origin, go to the left, 1, 2, 3, 4. We go to the left because it's negative. And then we're going to hit our function up here at a y value of positive 2. And f of negative 5. What is f of negative 5? We go to the left 5 here, and it hits it right here on the x-axis, and our y value is 0. Now we have an example of a Regents exam question. It says the value of f of x, the graph of f of x is shown below. What is the value of f of negative 3? So what do you think? What is the value of f of negative 3? Negative 3 is in place of x. So along our x-axis, we find negative 3. So we start at the origin, we go left, 1, 2, 3. And we trace that along, 1, 2, 3. Trace that along until we hit our function, which is right here. And what's that y value? Right here. And that's 1, 2, 3, 4, 5, 6. So what's the value of f of negative 3? Option 1, 6. So to recap, all you're doing is looking at the value that's in place of the x, finding that along the x-axis, and then trace until you hit the function and check out the corresponding y values.